Example number 2, we want to check if Roger has a healthy red blood cell volume. We know through research that the normal red blood cell volume is 28 milliliters per kilogram. So Roger had 7 blood tests done, and his 7 blood tests gave a sample mean of 32.7 milliliters per kilogram. And we're going under the assumption that the standard deviation for blood cell volume is 4.75 milliliters per kilogram. So it seems that Roger's blood cell volume is a little bit high, but we want to check how high, statistically speaking. We're going to do a hypothesis test, and we're going to run the test under the assumption that Roger's blood cell volume is equal to a normal person's. It's equal to 28. The question is asking us whether or not the data we collected indicates Roger's blood cell volume is different from 28 milliliters per kilogram. So for this hypothesis test, my alternate hypothesis is going to be that mu is not equal to 28. I'm not going to judge whether it's high or low, I just want to know if it's different. Now we can tell from our sample mean that, if anything, Roger's blood cell volume is probably on the high side. But a lot of times I do what's called a two-tailed test, where I want to test a claim, but I don't want to be biased either way, greater than or less than. I just want to check if that value is different from what I thought it was. I could run this same test on another patient, and that patient could possibly have a low blood cell volume, and I could keep the test structured the same way. So I'm going to do this two-tailed test, and I'm going to use a 1% level of significance. Meaning, the only way I'll reject the claim that Roger has a normal blood cell volume is if I'm less than 1% of making a mistake in doing so. So I don't really want to tell him anything's wrong unless I'm 99% sure something is wrong. To do this test, I'm going to use the standard normal distribution again as my sampling distribution. And the reasoning is that I know what sigma is, and in addition, although my sample size is low, I'm going under the assumption that the variable is normally distributed, which is told to me in the question. So I take Roger's sample mean of 32.7, and I calculate the z-value for that in the sampling distribution, which gives me a value of 2.62. So to have a sample mean of 32.7 is like having a value 2.62 standard deviations above the mean. Already it's seeming like that's quite high. To calculate the p-value for this test, since I'm doing a two-tailed test, what I need to do is calculate the probability that I can be 2.62 standard deviations away from the mean on either side. So I'm not guessing high or low, I'm going to do it for both ends of the distribution. So my p-value is going to be the probability that z could be greater than 2.62, but also less than 2.62 standard deviations below the mean. So each of these shaded sections is actually half of the p-value, and I need to total them up to get the p-value for my test. The simplest way to get this total, using my normal table, since my normal table only lists areas to the left of z-values, I'm going to look up the negative 2.62, because when I look up this z-value, I'll get this area directly. So if I go to my normal table and go to negative 2.62, I see I have a value of 0.0044. That's going to be the area to the left of negative 2.62. That's going to be this area right here. But what I'm going to do is that since the curve is symmetrical, I can just double that value, multiply it by 2, to get my actual p-value for the test. What I've calculated here is that the probability Roger could have a normal blood cell volume of 28 and have a sample of 7 tests that give me a volume of 32.7, that probability is less than 1%, 0.0088. Since that p-value is less than the level of significance I set at the beginning of the test, I'm going to reject the null hypothesis. There's less than a 1% chance I would be wrong in making that conclusion. I'm rejecting the claim that Roger's blood cell volume is 28 milliliters per kilogram. So it appears that there is probably something wrong with Roger.